In the higher tier exam, you might be expected to sketch some more difficult curves. For example, here's an example of a cubic curve. The reason it's called cubic is because it has an x cubed term in the equation. So y equals ax cubed plus b is going to be a cubic curve with a point of inflection at 0b. The point of inflection is basically just a point where the graph stops and becomes parallel to the x-axis and then carries on. You can see the gradient before the graph is the same as the gradient. Sorry, the gradient before the point of inflection is the same as the gradient after. So it might also be negative, point of inflection, negative. If a is greater than 0, the graph will slope upward. So we can see for the red graph, the blue graph, and indeed the orange graph here, a must be bigger than 0. And you can see the point of inflections. So here the point of inflections is 0, 1. So we can guarantee b is going to be 1. For the blue graph, b is going to be 0. And for the orange graph, the point of inflections at 0, minus 3. So that means b would be minus 3. This is an example where a is less than 0, and we can see that b is going to be 2. Here are some questions for you to try. I'd like you to match the pictures of the graphs with the equations on the bottom row. Please pause the video now and have a go, and when you're ready for the answers, press play. Okay, let's go through the answers. The first equation is y equals 8 take away 3x cubed. This is the same as minus 3x cubed plus 8. Y equals minus 3x cubed plus 8. We have a minus in front of the x cubed, which means that the graph is going to slope downwards. The only option there is the third one along, and just to confirm it, there's a plus 8 constant in the equation, and the graph goes through 0, 8. So that makes sense. We can see the first equation with the third graph. The second equation, 2x cubed plus 5, we know that it's going to have a turning point, a point of inflection at 0, 5, and it's going to be sloping upward, so that must be the last graph. Y equals 3x cubed plus 4, that's going to match with the orange graph, the second one, and 4x cubed plus 3 matches with the green graph, the first one. The next kind of graph that we're going to sketch are reciprocal graphs. As we've seen before, for example, the reciprocal of 2 would be 1 over 2. So whenever we have a reciprocal, you should be thinking about a fraction. So in the case of these type of graphs, it's of the form y equals a over x. This is what we call a hyperbola centered on 0, 0. The reason it's centered on 0, 0 is because it's just a over x with nothing added on. If a is greater than 0, it has the shape that we can see in this graph. The x and y axis are what we call asymptotes. Essentially, as x becomes very, very large, the graph will get very, very close to the x-axis, but will never actually touch it. Similarly, as x becomes very, very small, positively, so as x approaches 0, because we can't divide by 0, it means that the graph will become extremely large, but never hit the y-axis. And it's similar for the other branch of the graph. Here are some examples of hyperbolas, so y equals a over x for different values of a. Here's an example of a hyperbola again, and what we're going to do is change the value of a. So, for example, this is what will happen as a gets bigger. So remember, this is a over x. As a gets bigger, we can see that the branches begin to spread out further from 0, 0. Okay, so this is what happens when a, the number on the top, gets larger. On the other hand, as it gets smaller, the graph will contract back to 0, 0. And if we start to have values of a which are negative, so you can see the graph will change direction. So instead of it being like this, it will flip and it will then have branches in the opposite quadrants. So in the other two quadrants to the ones that the original graph had branches in. And then as a gets smaller, so it's getting larger negatively, we can see that the graph begins to spread apart. So here, when a is less than 0, the graph is reflected in the x-axis. And we'll see more of this in transformations of functions. The hardest type of graph that you could possibly see at this level is a graph with an oblique asymptote. But as long as we remember our straight line properties, it's really not that tricky. So here we have the graph of y equals ax plus b plus a over x. Sounds really complicated, but think about it. We've seen y equals mx plus c, so if I didn't have the a over x, that is just a straight line with gradient a. But we do have the a over x. The line ax plus b, y equals ax plus b, is an asymptote. So what that means is, as x becomes very, very large, the graph will begin to look exactly the same as the line y equals ax plus b. So we can see here that b is going to be 4, because as x gets very large, the graph looks very similar to the line y is equal to something x plus 4, because the y-intercept would be 4. And again, it's centered on 0b for that reason. So we know that b would be 4 in this example. An exponential graph is a little bit more straightforward. I think the hyperbolas are quite tricky. This is the graph of y equals k to the power of x. It's a very important graph where k is bigger than 0. The x-axis itself is an asymptote because as x gets very, very small, the graph will approach the x-axis but never hit it. Because any number to the power of 0 is 1, the graph will go through 0, 1, and it will have this general shape. It's important that we can identify the graphs that we've looked at today, even if you're not entirely sure yet how to sketch them. So I'd like you to have a go at matching, as before, the pictures of the graphs with the equations on the bottom row. Please pause the video now and have a go, and when you're ready for the answers, press play. Let's go through the answers. The first graph, 2x squared plus 3, is going to be a quadratic. The only quadratic here is the one on the end, here. The second graph, y equals minus 3 over x, is a hyperbola, and it's a simple hyperbola with an asymptote, with asymptotes of the x and y axis. So that's going to be this third one along. The next one is a slightly trickier hyperbola. We can see it has the 3x plus 4 part, which means that as x gets very large, it will approach the line 3x plus 4. Similarly, as x gets very negative, large very negatively, so down here, it will also approach the line y equals 3x plus 4. So we can see this is going to be the second line, the second graph. Finally, we have y equals 5 to the x. This is exponential. That's clearly the first graph because the first graph goes through 0, 1, and as x gets very large, it becomes very large, and as x gets very small, it approaches the x-axis.